types. The classification of O.D.E. number of differential equation. We have what we call the O.D.E. and we have what we call the P.D.E. Now, what does O.D.E signify? O.D.E simply means ordinary differential equation. Why P.D.E? P.D.E means partial differential equation. So O.D.E is ordinary differential equation, while P.D.E is partial differential equation. Now those are the two types of differential equation that we have, O.D.E and P.D.E. And what is the meaning of O.D.E? So we start with what definition for O.D.E. Let's start with the definition for O.D.E. You might be asked in the exam that you should define an ordinary differential equation. That you have to define an ordinary differential equation. What's the definition you are going to give for ordinary differential equation? Ordinary differential equation is defined as an equation that involves only an independent variable. The differentiation of a function of an unknown function with respect to only a single independent variable. Now, if we say that an O.D.E, this is an equation that involves the differentiation of function with respect to only one independent variable. So O.D.E is an equation that involves differentiation of a function with respect to only one independent variable. That is, if we have an equation, do you understand? And we want to differentiate a function. Maybe y is equals to 2x squared. Just like I said earlier. If you do the y dx of this will give you 4x. Now, if you look at it very well, this is a function. But anytime we are dealing with only one dependent variable, that is the y dx is a single function here, then we call it an O.D.E. Independence is very, very essential. You take note of this. With respect to only one independent variable. This is an equation that involves the differentiation of the function with respect to only one independent, only one. And what is your independent variable? It is your dx. Your dx is your what? Is your independent variable. An example of an O.D.E is, if I say the y dx plus y is equal to 0, this is an O.D.E. Can you see the way my D is? It is a normal D. The y dx plus y is equal to 0. I can write it in a linear form as y prime plus y is equal to 0. It's still the same thing. Y prime plus y is equal to 0. It's still the same thing. It's to show that I'm differentiating with respect to x, just only x. Another one again is I can write like this: the square y dx squared plus 2y is equal to sine y. So far I'm differentiating with respect to x alone. Then I can say this is a what? This is an O.D.E. Now, let's talk about P.D.E. We said O.D.E is an equation that involves differentiation of function that with respect to only one independent variable. You will notice that my D is this, and I'm using a single dependent variable In fact, I can write it like this again. The square y dx square plus the y dx is equals to 0. Or I can say it's equals to sine y. Although I'm having two derivatives here of different form, we are still coming to that. The square y dx square plus the y dx. This is dx, this is dx. So for it still having the same independent variable, then I can still say this is an O.D.E. So far, it is with respect to a single what? It is with respect to a single independent variable. Then I can still say it's an O.D.E. Lastly, I can still change it again and say that okay, what about if it is the square u, the y square plus the y, let me use on the variable, dv, dy is equals to cos u. If I want to differentiate this, it is with respect to the y. It is with respect to y. Abi? It is with respect to y. uv is my dependent variable. Y is my independent variable. So now I'm still having my denominator as a single variable. It is with respect to one independent variable. Then it is an O.D.E. It is still an O.D.E. Take note. So no matter how lengthy my equation is, so far I'm still having it with respect to a single variable, independent variable, then it is an O.D.E. That is the definition for O.D.E. Now let's